I know what I'm doing. No problem. So do you guys have any questions on this? That's okay, right? I just want to go fast because I do have quite a bit to teach you. How about finding the domain of these functions? Are you okay with that? Like this one, do you understand why this one, the domain has to be, x has got to be greater than 0? Okay, because you can't have a 0 down here, but also you can't have a negative number in the square root, right? So that has to be greater than 0. Domain of this would have to be that x is what? Did we do this one? Did we have to do this one? 11? So x has got to be less than 2 minus x. Let's do that. Should we do that one? For this one, 2 minus x has got to be greater than or equal to 0, right? So that means that negative x has got to be greater than or equal to negative 2. And then if you multiply through by negative 1, the sign flips, and you get x has got to be less than or equal to 2. Does that make sense?
So there can be a 0 underneath the...
Yeah, you can have a 0 underneath the inequality sign. Okay, questions on that one? Okay, can you two guys stop talking and take out your homework, maybe, please? Thank you. Do you have another one that you have questions about on here? Oh, I heard some people say, I bet you had questions about 43. Did you have questions about 43? Did you do that one? Did I do that in class yesterday?
You discussed
I kind of discussed it. Do you want me to go over that one?
Yes.
So with this one here, watch this. I bet you guys don't know what this button does. Watch this. Zoom in. That doesn't work. I do. I don't want it to be blue. But with this problem here, it's going to turn out and it's going to be blue. I can make it bigger, right? So with this problem, what you're supposed to find is find the average rate of change from 2 to x. Is that what they say? Find the average rate of change between 2 and x. So whatever it is, so the average rate of change, remember I told you, is that's the slope of this secant line. And so what you want to do, that's f of x, and in this case, minus f of 2 over x minus 2. Okay? And so f of x, in this case, is just what it is right there, 2 minus 5x. And f of 2 is what you get if you plug 2 into here. If you plug 2 into here, you get 2 minus 10, which is negative 8. So we end up getting minus 8, which becomes plus 8. You understand that? Because it's f of x minus f of 2, and f of 2 is negative 8, right? And then over x minus 2. And then if you simplify this, you got to be kind of clever when you simplify this. So 2 plus 8 makes 10 minus 5x over x minus 2. And that's not enough. You have to simplify this more. And the way I factored out a 2 from there. No, not a 2, a 5, right? It's 5. And then I get 5 times 2 minus x, and over on the bottom I have an x minus 2. Well, I kind of want to cancel these out, but I can't because one is 2 minus x and one is x minus 2. So what I can do is multiply the top and the bottom of this by negative 1. Okay? And then what you do is you multiply this negative 1 times the 5, which gives me negative 5. And then up top I have 2 minus x, because I only multiply one thing up there by the negative 1. And on the bottom, negative 1 times 2 makes positive 2, right? And negative 1 times x makes negative x. So what ends up happening is these two things cancel out, and you get that the rate of change is -5. And that makes sense, because what is this the equation of? A line, and the rate of change is the slope, right? And so what that's telling you, that's a very, very long way to tell you that the slope of that line is -5. But that's only true if it's a line, right? If it's a curve, yes, like a parabola or anything else, the rate of change is going to change depending where you are on that curve. So the only time where the rate of change is the same all the time is when it's a straight line. Yes, ma'am.
Why do you want to multiply the negative one?
Why do I only multiply the negative? Because when you multiply something by a number, like if I want to do 3 times 5 times 6, right? That's not equal to 6 times 3 times 6 times 5, right? It's you just multiply one time by that. You know what I mean? Yes, that's right. It's just okay. Another one, class. Oh, you wanted me to do another one, right? Like what's my name now? Okay, one of the word problems. Okay, so that one with the tree I did. This one? Do you like that one? This one's the tree problem. That's our problem. But and I don't think I give you anything like that on a test. But let me just show you how to do it anyway, because it's a good one, and it kind of challenges your algebraic skills. Did anyone get this right, like without looking, without cheating or anything like that? Okay. So you have this tree here, and it tells you that you read the problem, and it says that if the beam is to be cut from a rectangular wooden thing where the width, this is the width, right? And what you can do is see this little triangle right here. Okay, this is the. What you need to do is find the depth. So is equal to the product of the width and the cube of its depth. See the figures. If the beam is to be cut from a log in the shape of a cylinder of radius 3, express the strength of S as a beam of blah, blah, blah. What is it to make? So you need to somehow come up with an equation in terms of X for the width and the depth. So what I said, if I drew a big triangle here, like this, right? See that big triangle? Right there? This is D, right? And this is X. And what would the hypotenuse of that right triangle be? 6, not 3, because that's a radius, right? So you know that D squared plus X squared equals 36. Everyone see where I got that from? Right? Because that's a depth. But then you need another equation. Well, you don't really need another equation. You know that the width is just X, and you want the width and the cube of its depth. So I need to get an expression for the depth in terms of X. And that's not that bad. You go D squared is equal to 36 minus X squared. And so D is equal to 36 minus X squared, the square root of that, right? See that? Okay. Now you could write an expression for the strength, which is its width, right? Its width, which is X, times the cube of its depth. So if its depth is the square root of 36 minus X squared, the cube of its depth would be that whole thing raised to the third power. Or you could call that raised to the 3/2 power. Now it says it's proportional to, right? And so what they do is they throw a K in here for the proportionality constant. Okay, it's not exactly equal to this, it's proportional to that. So you have to throw a K in. Okay, so that's kind of, yeah, that's, I don't know, that's hard. But it's a good one. You want me to talk about 85? Because that's a good one too. Yes? Okay. 85 is what? 85 is similar. Oh, I don't have it on here, so I'll just. It was easy. You had X. Did you? Yeah, but I don't want you to guess and check. Wasn't 85 where you have given a perimeter and an area? Yeah, I want you to be able to do that algebraically. What did you do? Did you do it? Nah, no guessing and checking.
Easy numbers.
Easy, yeah, but that's kind of cheating. But so I want to start with a rectangle. Rectangle. Here's a rectangle. I'm going to draw a rectangle. See how good I am? Got it? And then they say that this is, we'll call this X for the width and Y for the length. And you know that the perimeter is what? 2x plus 2y, and they tell you that that is equal to something. 20? Is that what they say? 16. That's the perimeter. 20 is the perimeter, right? So 2x's plus 2y, and x times y is 16, right? Because they tell you that's the area. So I don't want you to use guess and check. Yeah, these are easy numbers, but really we're trying to teach you algebraic. It's nice that you have easy numbers so you don't have to, so that things work out. But they don't really want you to do that. What they want you to do is to solve one equation in terms of one variable. So if you know that 2x plus 2y equals 20, I could solve I could either solve this equation for y and plug it in here, or I could solve this equation for y and plug it in here. I'm going to do that. I'm going to solve this equation for y. So y equals 16 over x. And then what you do is you take that and you put it in there. When I do that, I have 2x plus 2 times 16, right? Which is 32 over x equals 20. See what I have now? Now what do I do? How do I get rid of this x on the bottom? Multiply everything by x. Yeah? And when I do that, I get 2x squared plus 32 equals 20x. And then you subtract 20x from both sides, because I'm going to try to factor this thing. Plus 32 equals 0. And then I'm going to divide everything by 2, which I'm about to do. Divide by 2, because that will make my factoring easier. So I get x squared minus 10x plus 16 equals 0. And then I factor that to x minus 2 times x minus 8, which tells you that x equals 2 or x equals 8. Okay? And so that means the length is 2 and the width, or the length is 2 and the width is 8, right? Or vice versa. Yeah? Okay? And that's how they want you to do that problem. They don't want you to use guess and check, because really, I hate to keep harping on this, but they're trying to set you up for calculus, okay? And when you do calculus, they're going to ask you to put the equation in this form and find what area would maximize, what would be the dimensions that would maximize this area, and then you're going to have to take the derivative of that and all that kind of stuff. But they're really, the idea here is they really want you to solve one equation in terms of one variable so that you can figure out how to do it. Okay? The end on review.